Hi all, welcome back. I'm going to be going through assignment 3 for this video. And so I'm starting from the very beginning this time. My stuff will look slightly different than yours in terms of folder structures. We're not in research methods at all. This is stats. And again, I'm doing what I always recommend you guys do, which is opening from the assignments folder so that it sets your working directory correctly. So we'll open this guy here. Blah, blah, blah. It's angry at me for stuff. That's fine. File, new file, our markdown, assignment 3, output to Word, OK. Again, get rid of all of this crap down here. And so if you read the top of assignment 1 or assignment 3, and you should always be reading the assignments in addition to watching these videos, I'm making an assumption that more or less you've learned the lessons from the first 2 assignments, that you have read the chapter for this week, that you've read some of the lectures, because this assignment's going to focus on like data distributions and aggregation. And so I am assuming that you can create in our markdown file, that you understand how to like add text, add headers, add code chunks, that you can install and load R packages so that you can use both the install packages function and the library function, and that you can read in SPSS data and use the pipe operator and ultimately knit. So if you don't remember how to do any of those things, go back to assignment 1. And scrolling down. Okay, so for part 1, we're doing that standard assignment 3, 1. I'm going to go ahead and save this now. Yep, there's the data sets there. So 2023, 126. If you're wondering why I write the date this way, it's because it will sort all of your files by date if you sort quote unquote alphabetically. So this is like a benefit of doing this on a computer specifically. So I always recommend year, month, date for file names, or for when you're writing dates in files. Ducate. 5305. Assignment 03. Okay. Done all of that. And then we have this R markdown document contains my work. Remember, single asterisk will italicize for you. For assignment 3 is double asterisks will bold things. And 3 asterisks will bold and italicize. Two. Okay. We got to load in some libraries. And part 2, step 2C tells you which ones you need. So we'll do library tidyverse, library here, library Haven, library SJ miscellaneous, library SJ plot, and library summary tools. And now you can just run this entire code chunk. There's a good chance you don't have summary tools. I actually wanted to show you what that would look like. Might actually, oops. Yeah, uninstall that. Okay, so let's assume that you're in this position and you haven't installed summary tools. But you try to run the whole code block. No package called summary tools. Oh, right, because I got to install it. Remember, when you're installing packages, you need to put quotes around the name, whereas when you're loading in packages, you don't have to do that, because R knows what the package tidyverse is, where it doesn't know the package summary tools when you're trying to install a package it doesn't have yet. Okay, so now I should be able to load. Perfect. It is telling you that certain objects are masked. What this means is that the package SJ miscellaneous has a function called desc, as well as summary tools. So they both have that. And so you need to, if you want to use one versus the other, you have to use that double colon notation to indicate which one from which package you want, because they have the same name. Okay. Read data into R. Did forget. Load libraries. Another code chunk. Again, I've mentioned this a couple of times, but you can, there's hotkeys for inserting code chunks. For me, it's Command Option I. Will auto insert all of this and then put your cursor here. That's kind of nice. You can also insert a code chunk this way, or manually type it, which is the least good of all of those options. Okay, so now we're going to read in some data to an object called states data 2012. Read SPSS here, data sets. What is it called? 2012 states data, probably. If you don't want to run this whole thing right away, sometimes I'll just do something like this and just see if this by itself runs. It does. That's cool. So we can go ahead and save this whole thing to an object. And now look, you can see down in your environment might be in your top right-hand corner, but wherever it is, you can see that it's showing that data has been loaded in, and there are 50 observations of 30 variables. And if we actually take a look at the data, makes sense that there's 50 observations because each line is some data about a state. So this entire data set is information per state. It's about states rather than people, which is what we had in the youth data set that we were working on last week. Scrolling down. You can also see the number of variables is here. So this is a data set. It has 50 observations, and then there's 30 variables. So like state is a variable, number 18, I don't know what this means, number rural, south, region, blah, blah, blah. You can scroll over and see all of them. And keep going. Okay. So now we want to view the variables in the data. In SPSS, you can click variable view, but remember, we do things the hard way here. So you're going to insert another code chunk, type states data, view df, which we learned last time, and then run that code chunk. And here we go. We get the basically the list of variables with their labels, their values, and their value labels where relevant. And so this is actually all you need. We can pop this out. You guys can't see it, but I'll move it back to the screen so we can pop it out into a browser window if we want to see it more easily there. I kind of like this. We can then go to our assignment. And I am assuming that you've done these. These are in the book, or these are from the book, but you don't need R or any of this assignment 3 stuff that we're doing to answer these top questions. But these you do. you should be able to answer what the unit of analysis is for this data. And take mind, I said unit of analysis, not level of measurement. This is where running this command is helpful. So for each variable, you're going to want to look and see, is it qualitative or quantitative, and what's its level of measurement? So this will help you somewhat, but it's not perfect. And so what I'm kind of expecting is that you do a little bit of digging into it. So remember, you can do things like states, data, attributes, labels. Actually, that's still going to be null. Oh, right, because I'm not actually picking a. So it'll kick out null to you if you don't specify this command specifically. The attribute function will kick out null to you if you're trying to push an entire data set through, because it doesn't, like, your whole data set doesn't have a label. Individual variables do. So what I actually care about is something like this. So labels. And the reason I'm doing this is because the output's emitted, probably because there are 50 states. But I'd just like to make sure. Oh, interesting. It's still not letting me do this. Cool. Well, something else we can do. And again, this is all optional. I'm kind of just showing you how you can play around with things, but as you'll notice, things don't work for me either. Sometimes you're just guessing what to do. But we can see the output for just the states data is, for this variable, is just the names of states. That's what's in that variable. We also saw this when we just took a peek. Here you can see state. And so you can also just use this simple view. You can also type states data here, gives you the same thing. This will also tell you things about your variables. So I will leave it up to you whether the states variable, for instance, is qualitative or quantitative. I'll also leave it up to you what the level of measurement is. We then have something like a murder cat, which I think is a fantastic name for a variable. But again, you should be able to either, you've got a bunch of options. You can either look here and scroll down. So this is murder rate, which is different than murder cat. Murder cat is down here. And so again, this is this variable. I will leave it to you whether or not you think it's qualitative or quantitative and what the level of measurement is. Burglary rate, median income. Again, you should be able to just use this and get your answer. So now we have to go back to the instructions for part 3 to make some frequency tables. So I'm going to create another header here. Whoops. Part 2, no, part 3. And right? Yeah, part 3. Assignment 3.3. Oops. Frequency table for murder cat. It should be like a band name or something. This is amazing. I love this variable. It's geniusly named. Blah, and states data 2012. Okay, make another code block or insert another code chunk. Code chunk, code block, same thing. So we are going to use a new function. We're going to use the frequency function. You can see here, there's there's a couple of different frequencies, honestly. We're going to use this first one, this FRQ, from the SJ miscellaneous package. we're going to ask for information about MurderCat. Notice that it also autocompletes for you. This is relatively new in RStudio, and it's very nice. It used to not autocomplete when you piped things, but now it does. We press enter, and we get this little frequency table. And so we can see a value of 0 has the label of 0 to 3 murders per 100K. And there are 17 states that have that value, which is 34% of the sample. If you want to check that for yourself, R can actually be used as a calculator. And so you can actually say, okay, 17 out of 50 is going to be 34. So that's kind of cool. You could ignore this percent valid. This is a different thing we're not going to get into, but then you have these cumulative percentages. So it sort of adds it up for you. So there's 34% have 0 to 3 murders per 100K. 76% have 0 to 3 or 3.1 to 6 murders per 100K, et cetera, et cetera. So there are actually a bunch of different ways to make frequency tables. And so we're going to try a different way now, just for funsies. Dates data. Oops, MurderCat. And it gives you something similar. Minimize this. So you can see it tells you slightly different things. You get different amounts of control here. A big difference is that the FRQ command tells you what the label is, whereas this doesn't. And so if you're looking at this frequency table, you need to keep in mind that these 0, 1, 2, 3, 4s do not mean like 0 murders, 1 murders, 2 murders. In this particular case, you've got a like ordinal level murder rate variable. So you need to check what the labels are. What does a 0 mean in this particular context? Because it doesn't mean 0 murders. And so you might be thinking, this table looks worse than this table. Why the F would I use this one? And the answer is because you can sort by frequency. So what we're going to do, and this is corresponding to part 3, step 4. Something else you can do, which is probably best practice, but I tend not to do it, is summary tools. And that way you know you're calling the exact right one. And SJ miss. Oops. It doesn't change anything about the output. It just lets you know which package is calling this particular function. Okay, so now we're gonna sort. So we're gonna do the same states data, pipe to summary tools, frequency, MurderCat, rude. I prefer autocompletes more than I prefer calling my particular packages. But then we're going to add this cool thing called order equals. Notice it wants to autocomplete for me because it's delightful. Frequency. Now, if you're wondering what are all of these other options, because I tend to like that, like what are all of these different things, you can actually go to the help file for it. And so what I'll do is I'll typically just write question mark freak, and it'll pull up my help file. The nice thing about this is that it tells me a lot of different options that I can put into my function. So there's extra things I can do. We were initially just using it in its most basic form. We were saying, just tell us the frequency of murder cat. But it turns out you can do other types of things, like you can change the order. Now, you'll notice that it's got some defaults. So there is like a default ordering to it. If you're wondering, well, what are my other options? You can actually scroll down here and see the different, they're called arguments. So for order, the character, which means you have to put the answer in, or put this in quotes. You can order the rows in your frequency table by name, by level, by frequency, and by negative frequency, which is reversed ordered. So level is the default for factors, which is what we were dealing with. But we want to order it by frequency. So that's what we're going to do. So you'll notice it looks the same, except it's now, as expected, ordered by frequency. So a response of 1 in this variable has the highest frequency. We can see up here, response of 1 means 3.1 to 6 murders per 100K. So that is like the most common value for this variable amongst different states. That means that the most common murder rate across the 50 states is somewhere between 3.1 to 6 murders per 100,000 people. Cool. We can also reverse order this by negative frequency. I said negative frequency, but it's not really negative frequency. You can see the least to most common. 3 and 4 are actually equally common. Again, we can go up here to see what those numbers correspond to. Also, remember you've got this that you can take a look at as well. It should also still be in your viewer. So lots of options to figure out what those codes actually mean. You can also clean these up a little bit if one is so inclined. And so one way you can do this is do it like that. Plain ASCII is false. Note that this is a Boolean answer, which means it's either true or false. You don't need to put quotes around it, but it does need to be in all capitals. So like false won't work. One of the ways you can know is because, again, it's going to want to try to fix this for you. But also trues and falses show up in a different syntax highlighting. So in my case, it's pink. You can also actually just use F and T. That also works. I like to, in general, write out the whole thing. So false, style equals R markdown. In this particular case, whether you use single or double quotes doesn't matter, I don't think. Oh, as a side note, because it just got angry at me for this, RStudio does a cool thing where when you have an error in your code, a lot of times it'll pop this up. So right now it's telling me that there's some unmatched opening bracket. What it's noticing, and you can see if you zoom in about how to do this, super close. There was like a little red line here at one point. See if I can. Sometimes it will highlight where your issue is sort of my point. So let RStudio work for you. Okay, let's try this again. It's a little bit funny, but this is another like nicer way of, or different way of displaying some of this. It'll knit better when we actually knit it. Let's see if we can go ahead and do that now. Scrolling down. Yeah, see, this would work a lot nicer. Oh no, this is just our data set. That's fine. 6 of one, half dozen of the other. If we knitted it to something nicer, it might look nicer, but it's just different options. I think it's more likely to look nice when you do something like knit to HTML. But shrug. Something else that you can do is change your the options in your code chunk itself. And this is the last thing that I have you doing in your assignment. Is that there are actually options you can add to individual code chunks. So results equals this, and we will still, oops, leave that there, copy that, paste that. I think if we knit, get something that's a little bit nicer. So this is going to play nicer in something like Word. It's going to play nicer in HTML as well. But basically it turns this format into this, which you can work more with if you're writing a paper or something. It'll look even nicer if you were to knit to HTML, for instance. Or even PDF, which I don't have you do because it has lots of problems. But you can see like this looks a lot nicer than this particular output. You can do more with it. And so this sort of gets you through the rest of the assignment. You should then have everything you need to complete questions 7 and 8. There's a short chance I'll add a couple more questions to this before the end, but probably more in the front half rather than the back half. But you should be able to use these outputs that you just created to answer these particular questions. Also, as a fun bonus side note, I know this is getting a little bit long, but if you run all 3 of these, you get all 3 outputs in one go. So you may want that, or you may want to put them in their own separate code blocks. So I noticed we get all this nonsense. This is because the Vue.df doesn't render very nicely in Word. And so you can just comment that out. Again, you don't have to do something like this, but you can see there's ways to sort of play around and dig into your data, even outside of what I'm describing in the assignment. So feel free to play around. Feel free to look at the help things. I'm blanking entirely on what these are. The help files to get a better sense of what is your individual function doing. So you could do this for see, we did this for frequency, but you could do this for the other one. It's also going to tell you your other options. Most of these are not going to be very meaningful for you, but you can sort by frequency as well. And so that's kind of cool. I had not seen that recently, or I had forgotten it. So it's always worth digging around in the help files, even if you're not going to do anything with them, just to see what the output looks like. So like I said, that should get you through assignment 3.